Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. We're working in your Saxon Algebra 1 book, the orange book, and we're on lesson 5 today. So we're talking about sets, absolute value, and adding signed numbers. So in part A, we're talking about sets, and sets are simply well-defined collections. Very often of numbers. So we're going to talk about sets of numbers. And so here is a set. A is, and we got this little bracket thing here, 1, 2, 3, 4, 5. And so we could say that those are the elements of set A. So if we were going to talk about a set that we're going to name, we're going to give this set a name that is the same name that everyone all over the world uses for this same set of numbers. We're going to define the natural numbers as the numbers 1, 2, 3, 4, 5, 6, ... Okay, so when we have ... usually 3 dots, that means it goes on and on forever. And our natural numbers go on and on forever in one direction. So we do not have a 0 because the natural numbers are the numbers you naturally start counting with. So when you're a little child and you start to count objects like spoons or forks or toys, and 1 car, 2 cars. So you're counting the objects, and those are called the counting numbers and the natural numbers. So whole numbers are the natural numbers plus 0 added. So the whole numbers is what we call the numbers 0. 1, 2, 3, 4, 5, 6, ... So the only difference between the natural numbers and the whole number set is the 0. The 0 is included in the whole number set. The 0 is excluded from the natural numbers. Now we have one very important set that we usually see labeling our number line. And this is the set of integers. And the set of integers are the natural numbers plus 0 plus all the opposites of the natural numbers. These are called negative numbers. And our set of integers is all of those. So including all of the positive natural numbers, 0, so it includes all the whole numbers, but then it includes all the opposites of those. So we're going to be learning a lot more about that set of integers as we move on here. Now we're going to talk about a concept called absolute value. And the absolute value is really quite simply the distance that a number is from 0. If I jump in my car and I drive to school, and that's about 2 miles. So I jump in my car and I say I traveled 2 miles. When I jump in my car to travel home from school, do I say I went negative 2 miles? No, I still went 2 miles back home, right? So when we're talking about distance from 0, that's a good concept to use for absolute value. It's always going to be a positive distance. Even though I'm traveling from home to school or from school to home, I'm still burning gas and I'm still traveling 2 miles. So it doesn't matter. We don't say 2 miles one way and negative 2 miles the other. We just say 2 miles. Okay, so when I'm looking at numbers on the number line, and I look at the number 2, and I look at the number -2, aren't they both 2 steps from 0? So if I'm at the 2 house here, I take 2 steps to get to 0. If I'm at the -2 spot, I take 2 steps to get to 0. They are both 2 steps from 0. Direction is not being considered here. So here, let's look. This symbol of 2 lines that are a little bit bigger than the number, this is the absolute value sign. Straight lines down. The absolute value of 0 is always defined to be 0. So that's one of our rules. The absolute value of -7.12, which we know properly read is -7 and 12/100ths, we're going to say it is 7.12 or 7 and 12/100ths. We leave off the negative because we have this absolute value says, what is the distance of that number to 0? 7.12 steps. Okay, so the absolute value of positive 7.12 is equal to 7.12. It doesn't matter whether I did the absolute value of the negative or the positive, the sign is irrelevant. So then the absolute value of a negative 5 is 5. So now we can actually do problems with this. So let's look at this one. We have the absolute value of 11 minus 2. And we have to do the 11 minus 2 before we take the absolute value. So this simplifies to the absolute value. 11 minus 2 is 9. And the distance of 9 to 0 is 9 steps. So the answer is 9. Okay, here we have one a little bit more complicated. We have a negative outside the absolute value sign. So that negative is not acted on by the absolute value. So we start at the inside. 20 minus 2 is 18. So we're going to have negative the absolute value of 18. And then we say, well, what is the absolute value of 18? And that's going to be positive 18, right? So we have negative 18. This negative out here is unaffected by the absolute value. So we found out the absolute value of 18 was 18. And remember, a negative in front means the opposite of. So the opposite of an 18 is a negative 18. And that would be our answer. So we're going to be doing some of those in our problem set. Now in section C, we're going to have some fun adding signed numbers. So we can look at the positive or negative sign as if we're using the negative, we're going left, and the positive, we're going right, because the positive is moving to the right on the number line and negative is moving to the left. So if we're going to do 3 plus a negative 5, we start at 0, and then we take 3 steps to the right. So 1, 2, 3 steps to the right. And then from there, we will take 5 steps to the left. Okay, so basically we're turning around here and we're going to go 1, 2, 3, 4, 5 steps to the left. And we wind up at negative 2. So here's our negative 2 that we wind up on. So that's the answer, right? So the answer is negative 2. So let's do that same problem in a different order. Let's put the negative 5 first and the positive 3 after it. So we're going to add a negative 5 plus a 3. So here we'll use the underneath of the number line here. So we're going to start at 0 again, and we're going to go backwards 5 steps. So 1, 2, 3, 4, 5. And now we're going to go forward 3 steps. 1, 2, 3, and where did we wind up? We wound up at negative 2 again. Well, that makes sense because we wound up at negative 2 last time. And now we have negative 2 this time also. So that is illustrating what's called the commutative property of addition. And the commutative property is the property that says it does not matter which order we add in. So 4 plus 3 is 7, and 3 plus 4 is 7. And they both gave us the same answer. So 3 plus a negative 5 is negative 2. And negative 5 plus 3 is negative 2. Okay, so now we're on example 5.4. And we have our number line. And we have our numbers that we're adding together. Add together positive 2 and positive 1. And when they have the signs on them, your book is calling them directed numbers. And that's fine. That's a great term. So positive 2 means that we're going to start at 0 and go 2 steps in the positive direction. And then positive 1 more, we're going to start there and go 1 more, and we're going to wind up at a 3. So we could say that 2 plus 1 is 3. Now we know that positive 2 and just 2 are the same thing. Okay, so down here, we have add negative 2 and negative 1. So we start at 0, negative 2, and then 1 more in the negative direction. So we go 1 more in the negative direction, we wind up at negative 3. So negative 2 plus a negative 1 would be a negative 3. Okay, for our last practice or last example before we start our practices, notice what we have here. We have negative 4 plus 2 plus a -1 plus a +5. And then down here at the bottom, we have the same numbers, but we have them in a different order. So we're going to do them in the order, and since they are the same numbers added together, shouldn't we wind up at the same spot, no matter which order we're doing it in? So let's do the top one on the top of the line and the bottom one on the bottom of the line and see if they wind up being the same. So here we have a -4, so we start at 0, and we're going to go 1, 2, 3, 4 for the -4. We go backwards. And then we're going to add a +2, which means we're going to go to the right. So 1, 2. And then we're going to add a -1, which means we're going to go to the left from that spot. So we're going to go -1. And then from that spot, we have to go 5 positive. So from this spot right here, we're going to go 1, 2, 3, 4, 5. And we are at 2, which should be the correct answer. Okay, so now we're going to do the same thing, but we're going to do it on the bottom of the number line, and we're going to do it in this order. Since we have the same numbers in a different order, shouldn't we wind up at 2 again? Let's see if we do. So let's start at 0, and let's go -1. So here's 0. We're going to -1, +2, which means to the right. So from here, we go 1, 2, and then from this stopping place, we're going to add a -4. So 1, 2, 3, 4, and then a +5. From right there, from wherever we stop, we do 1, 2, 3, 4, 5, and guess what? At 2 again. These are your 4 practice problems for your absolute value. The absolute value of a -4 is the distance of a -4 to a 0, which is 4. Okay, and then the absolute value of a 4.2 is going to be 4.2. So positive numbers don't change, do they? The absolute value of negative the absolute value, so that will be the opposite of 10 minus 6 is inside the absolute value. So we can simplify this in stages. So we have the negative, which we'll deal with in a minute. 10 minus 6 is 4. Now the absolute value of 4 is 4, but then we have the opposite of the 4, so the answer will be -4. And the last one on this part, we have inside the absolute value -14 plus 6, and -14 plus 6 is a -8. Now that's what you would get if you put those numbers on your number line. -8. We're going to be talking about the rules. When we have opposite signs, we subtract the numbers and take the sign of the greater. So we'll be doing more of that later. This one you're supposed to still be doing on your number line. -8 inside the absolute value. The absolute value makes that a +8. So we had negative absolute value of a -8 is the negative of a +8, or -8. That would be our final answer, and there is your board for those practices. Okay, so here we have our last few practice problems here. +3, so we're going to start at 0 and take 3 positive steps, 1, 2, 3. And then from there, we will take 2 more positive steps, 1, 2, and the answer is 5. On the next one, we have a -3 plus a +2. So we'll start at 0, and we'll move in the negative direction, 1, 2, 3. And then from there, we will move 2 to the right, 1, 2, and the answer is -1. And the last one, we will draw a number line here, 0, 1, 2, -1, -2, -3, -4, -5, because we're going to start and go -5 at the start. So ready? 1, 2, 3, 4, 5. And then we're going to move forward 2, 1, 2. And now we've got to move backward 3. Uh-oh, I'm going to go off of my little chart here. We're going to have to make that one right there -6. So 1, 2, 3. But then what? Lastly, we move forward 3 more. So 1, 2, 3, and we're back at -3. So the answer is -3. And I'm out of room, but that's okay because we're done with our lesson and you can go do your homework. And this is Mrs. A, and may God bless your day.